Hello and welcome to this workshop of the Applied Artificial Intelligence Conference. My name is Matthias Grabner. I'm with Advantage Austria, and I'm coming to you now from our second studio because we have quite a few smaller workshops going on at the same time. This workshop is hosted by H2O.ai by Lena Rampula, the lead data scientist at H2O.ai. And let me just quickly see if I already have a connection to Lena.
Hello, everyone.
Hello and welcome. Hi. This workshop is titled Navigate Your Way Through AI. And you will give some hints on best practices of how to implement AI yourself being a company that is looking into realize their own AI strategy. We will be again offering you the possibility to ask questions live and to interact. But without further ado, I would give the stage over to Lena, your host for this workshop. And Lena, do you have any questions before we start? People are logging in right now. They are.
No, I'm ready to go. I'll just share my screen and
yes, let's
start.
See if that works. And all right, and here we have your screen. Then I wish you a successful workshop. I will be also in the chat, should there be anything, and talk to you later.
All right. So welcome everyone to this workshop, which is named Navigate Your AI Journey, 5 Takeaways for an Impactful AI Implementation. I'm Lena Rampula. I'm with H2O.ai. I'm a data scientist in H2O.ai, and I work on projects with our customers implementing different use cases with our platform. And today I would like to share some insights from the projects that we implemented together for customers and give you some hints on what would make an impactful AI project. So first of all, let's start from the end. What impact actually looks like. We can map impact into reducing risk, reducing cost, and increasing revenue. What does that mean? So let's take, for example, a use case of fraud detection. When you do fraud detection without a machine learning algorithm, usually you would write some rules that you use to identify fraud. It's not possible for a person to actually go through all of the transactions and identify which ones are fraudulent and which aren't. So usually companies, before they would implement a machine learning model, would have some complex rules that identify those transactions. An AI project that implements a machine learning model for fraud detection would immediately bring business value to the company by reducing the risk of having fraudulent transactions, increasing revenue as well. And by introducing a project that is automated and finds those transactions automatically, you would reduce the cost of maintenance of the rules and keeping resources that have to do this type of work. When we put it all together, what we are calculating is return on investment. And return on investment is practically the amount of effort you put into implementing the project and how it compares to the value that it brings. So impact, from my perspective, is what is the size of that return on investment that we gain from implementing an AI project. So before starting any project, ask yourself, what is the end goal? What will happen if you don't do the project? And what success actually looks like for you. Here are some examples of our customers and the type of business value that they're gaining by using AI. Some of them may be some reduction in costs, reduction in planning time, savings. Some of them are about increasing the number of customers that they keep. Some of them are about making more accurate predictions. And all of those were implemented with AI, with those type of gains that you could expect from that type of project. So in my experience, the five pillars of an impactful AI project, although there are many factors that may break or make your project, in my experience, the most important one is involving the right people. So who needs to be on your team to make the project a success? And as much as I would like to give us data scientists the most of the credit, we are not the most important part of the team. The second one is ask the right question. So AI is all about what are you trying to find, to answer, predict, and we would talk about what type of questions AI can actually answer and what type of questions will bring you the most value. Then you need to identify the right data to answer your questions. And here as well, there are different types of data that you would need to have in order to answer AI questions. And there are many aspects of how to collect data, how to integrate it, and how to actually gain value from it. So this is another pillar which is really important. And then you need to select the right technology. So what is required from your AI platform? AI is more than just a machine learning model. So what else the technology needs to support for you to have a successful project? And finally, to make impact, you have to show the value. Make the solution usable and useful for your business users. So who is on your team? In my experience, unfortunately, in many projects, business users are actually not part of the team as an integral part of the team. And that's a shame, because I think that business users and business experts are the most important part of the team. Those are the people who actually know what is the value of the project. They would know what value they can bring to the business. Those are the people who are going to use the solution in the end. And without them being on board with the solution, there is no adoption. And this is the core the core thing about a successful project that needs to be used. Moreover, business experts have domain expertise that usually would bring you the competitive advantage over other solutions. Domain expertise and business know-how is as important as data science expertise. Then we also need to have other experts, data experts and IT experts on the team. Data engineers are really important, and they have to work with the business users to actually integrate the data, get the data from the data sources where it is kept, make sure that it's in the right form for the data scientists to actually build a model upon it. The operations team would then take the model and actually put it in production, monitor it, make sure that it's stable, make sure that it's running when the business users need it. And then the developers would work with the business users to see how actually they want to get the results of the model. Would they want that integrated into an existing tool? Would they want to have a new application built for them to be able to ingest that data? In general, as you can see, AI for the business is not only about data scientists building models. As any other project, it's a team sport. So what makes a good AI question? So we talk a lot, or I talk a lot about business value. And the most important thing is there business value in answering your question? So business value is subjective to every company. So I would not be able to tell you what is worth answering and what's not for your company. But before you start, it's important to stop and think about what is the value that you can bring with answering this question and how to calculate it. So you may want to ask yourself questions like, what is the dollar value of improving the business outcome? Or what is the productivity gain of using the solution? How many more projects you can implement with that solution? Or what the business users can do with their time more by using that solution? How much will you save on resources using that solution? So all of that translates to either increasing revenue or reducing costs, and that would translate to your return on investment. You need to know how to calculate that value. You need to involve the business users and the sponsors when you are formulating your question. Everybody needs to be aware of the goal, and the question is the core, which needs to be always thought of. Focus on solving a business problem, addressing a pain, or providing new insight. Now, what kind of questions can be answered with AI? So, of course, we have all kind of a crazy idea about AI. It can do everything, and it's just self-sufficient and can answer a lot of things. In business, we usually talk about 3 types of questions. Some questions are about forecasting numbers, or answering questions like, how much will I sell next month? Or even in one of our projects, we were answering a question of how many eggs will be laid by chickens in a farm, and also predicting daily earnings or anything else that actually results in a number. So those would be questions that you would ask how much or how many, and get a number in the end. Another type of question is a categorical question, where the end result is either a label or a category, and those questions are yes/no questions, or which one of those items in the category will I choose? So, for example, will the customer churn? This is a yes/no question, and we want to predict one of the outcomes, either yes churn or no churn. Or it can be maybe whether a customer will click on an ad on a website, or maybe which product the customer will buy next. So that would be one from a category. There are also questions that are a little bit more difficult, a bit more tricky for us to implement projects around, and those assume that there is some kind of a pattern in the data that you can detect, and they want to discover that pattern. So there are no predefined groups, no categories, and an algorithm is applied to find that type of grouping in data. And those questions are the hardest to evaluate because there is no ground truth. Another aspect of asking the right question is about being concrete. So following the previous point, try formulating the question in such a way that it can be answered with either a number or a category. So the first question is open-ended. How do I improve customer experience? There may be a lot of answers to that question, but it would be difficult for you to actually answer it and be able to evaluate the results of your answer. A different question can be asked in similar area. What ad should I show to this customer? This is a classification question where you have a number of ads or products, and you want to select the one to show to the customer. So this is something that will result in a category, and it's either correct or not, right? So you would either predict that the customer would click on that ad, and therefore your prediction would be successful, or you will show an ad that the customer is not interested in, and your prediction is not successful. Even though those are not per se questions, those are the type of use cases that we see with our customers. We work with different industries because our platform is not really specific for a specific industry. And for example, in the financial services sector, we see a lot of fraud detection and credit risk scoring. In healthcare, very interesting use cases around disease detection, like early cancer detection, sepsis detection, and also personalized medicine, or how many, what are in the pharma industry, what are the chances that a doctor would prescribe a specific drug to their patients. In telecom, churn prediction is very popular. Churn, or whether a customer would leave or not, is a popular use case across all industries, because we all have customers and we all want to keep them. In marketing and retail, next best offer and customer segmentation are very common use cases. So when you start and you want to start a project, really think about what you are asking. Is it possible to answer it in a way that is measurable? And if it's a question that AI can actually answer. Let's get to the data. So what kind of data you should use for your project? So you can find data anywhere, and those could be your CRM system. It could be comments and reviews from your website, transactional data, website analytics, some documents that you may have collected, sensor data that you collect from your product line, really anywhere. But what you need to think about is what data can help you answer your question. What is a good way to start is if you are looking to replace an existing process, look at the data that is already used by either by the people who are doing that process manually, or in the existing model that was built before. And that's a good start. And you can always think about how to enrich this data, what other information could be added, and so on. If you are looking at a completely new question and you don't have an existing process for answering that question in the company, try to think about what you would need to do if you would want to answer that question by yourself, right? So for example, if you're looking at detecting churn, what information about the customer you would need to collect to be able to guess if they may leave or not. For the data type that you would want to look for, is if you're looking to predict, for example, forecasting something or predicting numbers, you would want to see if you have historical data that has that information in it. So if I want to predict the sales next month, I would want to have in my data the sales the month before or a year ago, and so on. So my model would be able to learn from this information. So you need to have what we call labeled data. Many times in our use cases, we look at historical data. It's the same for questions that are classification questions. You also need to have data that already has that category in it. So again, if we talk about churn, this needs to be data about customers that already left the company before. And what the model will try to do is to understand what is the pattern of behavior or of characteristic of the customer that were leading to that customer leaving, and applying those findings to new customers that we don't know yet about them, if they're going to leave or not. So for forecasting and classification questions, the model needs to learn from data that already has the answer. For grouping questions, this is not necessary, and you can use data that just that doesn't have any ground truth, any label attached to it. In the recent years, there were a lot of advances in machine learning, and now we can use any type of data, from images, videos, text data, sound and signal data, time series, really any type that you could think of. For example, in manufacturing, there are a lot of use cases for signal processing and sound processing. You can use sound from machinery that maybe monitors your product line, and see if some changes in the sound may help you predict whether a product would be faulty or not. You can look at images to predict whether, for example, images that you would use in your campaigns, and predict whether a customer is going to click on your email or on your ad based on the characteristics of those images. So there are a lot of different things that can be done with data. In the end, all of the types of data are converted into a tabular format. And here the role of the data engineer is becoming really important, right? So the data engineer needs to work with the business user to make sure that all of those different sources and different types of data are linked together in the right way, that it really belongs together. It really makes sense to actually put them in this way, that it all works well. So this is the work for the data engineer. There are a lot of technology already that does the conversion into a tabular format for you. So it's possible to just have raw images, raw text, and still be able to have really good machine learning algorithms written for ingesting this type of data. Now, the most important part, and this is something that I think anyone or everyone heard already, is that your model is as good as your data. Beware of bad data. Machine learning algorithms learn from the data you give them. So if, for example, you want to predict weather, and you give your model only information about days that were rainy. So the model only saw rainy days, and it learned what it learned from that information, and you would like it now to predict on a sunny day. That model would not be able to do that because it never saw this information before. So you need to have the data as representative as possible of the real world, and it needs to contain only the information that would be available to it in the real world. So bad data also means training your model on information that is available only later on and not available at the moment that you would be using the model. And the model needs to be trained on data that is as similar as possible to the data that you would actually be using the model on. So, so you can imagine it's the same as you would want your students in a course that is going to have a test at the end of the course. You want to give them all the information they need to answer the questions in the test. If you are going to give them material to learn from that is different from what is going to be in the test, then they would fail the test. And it's the same for the models. They need to be taught the right information for them to be successful in the test. Another point, which is not so much about the data itself, but about the data culture in the company. So many AI projects fail because there is no data culture. It means that people or some individuals may not actually understand the value of data-driven decision-making, of machine learning, and they may be averse to change and maybe not convinced about the benefits that AI can bring them. And in my experience, to facilitate a cultural transformation, you need to bring those individuals on board and make them part of the team. Use their expertise and help them understand what value the data and the whole AI project can bring them. And data culture means that everybody understands the value of the data and are responsible in data collection and trust the data. So data quality is something that that can really break your project. And maintaining data quality is also part of your cultural transformation and data culture. There are also several other aspects that can cause bad data. We mentioned integration. So sometimes the data is not integrated in the right way. Maybe it's not of the same granularity, or it just was wrongly merged. And this is, again, the work of the data engineer. And many times the data engineer and the data scientist would not actually identify that the data was not integrated correctly. And the business users and the business experts would be the ones to identify and say, this data doesn't make sense, because they work with that data. So again, I would like to stress that including your business users in your project is really, really important. It could also be that you collected data that doesn't actually answer the question, or there is no information in the data you collected that can answer the question. That's also a possibility. And the last one is data bias. And data bias is a big topic that I would not be able to talk about a lot right now. But just an example, you may have data that is missing some minority group. And again, that would mean that the model would not be able to make correct predictions when it would see an individual from that minority group. And that would cause the model to be biased. And this is something that increases the risk of using AI models and needs to be taken care of. There are a lot of different methods to reduce data bias. Right. Now, getting the right technology and what technology you actually need to be able to implement this type of project. So beyond having technology that actually can support you in implementing the best model from perspective of accuracy, maybe you would want to focus on the time it takes you to build a model in that technology. AI implementation is not just about building a model. It's about much more, right? So first of all, you need to have the technology to explain your model. So if a model is not explainable, business users may be reluctant to trust it. And every model should be documented. Every model should be explained why it made the predictions that it made, what was driving this model, what factors are the most important factors, is the model fair? This is explainability. And this is an important part, especially in regulatory applications, so that there are areas where if you do not have AI explainability, you would not be able to use AI at all, especially in regulated environments. And similarly to involving the right people in the project, the technology should be able to support the whole end-to-end cycle of the AI implementation. So we are talking about model management and monitoring, being able to deploy the model, integrate it with other applications, and so on. Those are the areas where your operations team and developers would help you to bring that project into production. So again, I had experience where we would work on models and have really great results, but would not have the capability to actually bring that model to the business, not having the knowledge or the people to support us in building the integration with different applications. And what that means is that even if you have the best model, it has absolutely no value if you don't put it in the hands of the business users. There are some other technology considerations that you may think about. Open source, for example, is a good topic. There are many really great open source technologies, and there is always a consideration whether to use an enterprise technology or an open source technology. It's possible to use in the enterprise, even in very critical applications, open source technology. If you do have an enterprise implementation of an AI project, and it's very important that that project would be running and would not fail, be sure to have support for your open source technology. So many companies that have open source tools published would also offer support, enterprise support, and that means that they would fix bugs or any type of mistake that is happening in the code for you that may cause failure. And it also means that usually they would prioritize your features, requests, and really support you throughout this process of the implementation of the project. Build or buy. This question goes back to how you calculate your return on investment. It may be that that it would be more economical for you to build your own application. It can be that it's better to use a platform that already has an end-to-end solution. And really, it's about whether it's worth building something from scratch. If you would actually calculate the costs of the amount of time people spend on building it, and the value that you gain from having your own custom application. Consider looking into platforms that allow a lot of customization or allow for integration with your own knowledge and the know-how into the platform. Where is your data is also an important consideration. Does the technology has access to your data? Would it be able to load the data from where it actually sits right now, your data lake, your warehouse? Are there data connectors to where your data actually resides? And another question people ask themselves is whether to have a technology which is on the cloud, or technology that allows you to install their tools on premise. What we see is that in regulatory environments, we see more companies tend to have on-prem installations because of security of the data, and even though it's possible to also have secure environments in the cloud, there is a tendency to keep the data on premise, not to leave anywhere. And on the other hand, a lot of companies are now moving to the cloud as a strategy. So when considering technology, take a look at what your IT strategy is and align with it. So that, again, technology that aligns with your IT strategy. If your IT strategy is in the cloud, make sure that it can run in the cloud. If it's a strategy for on-premise, make sure that it can run on-premise. All right. So the last point is about showing the value. And in order to explain what showing the value is, I think the best way is to show you an example of a project that we recently implemented, and then show you how we decided to show the value to the business users. And before going into the details of the case, of this project, let me shortly introduce H2AI. So H2AI is a software company. We're an AI software company. We were founded in 2012, and we are a Series D funded company. We started as an open source company. So a lot of our early investment was into building an open source scalable machine learning platform, which is called H2O. And with that platform, we raised the community of data scientists using this tool. And there are more than 200,000 people actually using H2O. And also many companies are using our product in their businesses. More than 20,000 companies are using our open source technology for their business. And there is something special about the company. We're all data scientists. Most of the people in the company, 270 plus people, are all data scientists. And we also have in our team the best data scientists in the world that are helping us to build the products and also help our customers with more challenging projects. We have customers all over the world, and also the company itself is global. And the project that I would be talking about today was built with our automatic machine learning platform called Driverless AI. This platform allows data scientists to let the tool do a lot of the tasks that they would usually do manually. It automates a lot of the process that needs to go into building a machine learning model, so that data scientists could build more models faster, and very good models as well. We also used H2O Wave in this project. That's an open source low-code framework to build AI applications. And we also used the H2O AI hybrid cloud, which allows us to have an app store for the company, a private app store, to host H2O Wave applications. So the use case that I would like to talk about is supply chain in the COVID era. We were working with a company, an FMCG company, and in face of the pandemic, they needed to react fast to the changes that were happening in their supply chain demand. As many other companies, the pandemic caused disruption to the supply chain. The demand of different products changed and shifted from one type of products to a different type of products. And around the globe also, the pandemic was shifting, and the team had to adjust constantly to the changing demand in different regions. the bottom line of that use case is that the long-term forecasts that we built for them using years of data were no longer reliable. They couldn't use the same forecasts anymore for their supply chain, and of course we had to react really, really fast to that situation. So here we have a clear business need. We need to react to the situation and change the supply chain forecast so that the team could adjust what would be the supply to different regions and what needs to be shipped to which area and in which quantity. And in order to do that, we went through the stages and the pillars that I was talking about before. So first of all, building a team. We had a team of business users and business experts from the company, also data scientists on both sides, both the company data scientists and our data scientists. We involved also our domain experts on modeling COVID-19 and other modeling techniques that were specific to the situation. And because we realized that we would need to build an application for the business users to be able to access real-time information about demand, we also had developers in that project. And together as a team, we formulated the question that the AI project would be able to answer, and that is what will be the demand for different products in different regions next month. So the business user needs to know today what would be the forecast for next month's supply chain, what would be the forecast for the demand in different regions and products. But they need to do that on a daily basis. So every day that forecast may change and they would have to react to that change immediately. So this had to be an application that would be readily available in real-time changes and so on. The data for that project to help us answer that question, we used the existing supply chain data that they already had and used for their long-term forecasts. We also took data that is COVID-related, so public data sets about what is the evolvement of COVID around the world. And we also looked at macroeconomic data and other data sources that I will share in a second. And for the technology, we were using the H2O AI hybrid cloud, and with that technology, we were able to support the development of that project end to end. So from getting the data and ingesting it and creating a data set that can be used for modeling, the team, specifically our data scientists and their data scientists, were able to build a lot of different models. They had to do it really, really fast. So the system, the technology had to be of the type that would help us really experiment with the modeling and prototype really, really fast to get to the best model that actually can be deployed into production. As part of the technology, we needed to have something that would deploy the model, maintain it, and monitor it. And in the end, we also were using the H2O Wave to develop an application for the business users. And that application is being hosted on the App Store at H2O AI Hybrid Cloud. I mentioned our data science experts. So there is a data science competition platform called Kaggle. If you are a data scientist, you know about it, but it's something that like the Olympics of data science. So there are different competitions, and data scientists are competing with each other and getting scoring. And we have quite a lot of those experts that are scoring really, really high in those competitions. But specifically for this project, our data science experts were competing at the COVID-19 forecasting. This was a weekly competition, and they developed a model that continuously scored really high in those competitions. So we knew that there is real value in that specific model, and we integrated it to our supply chain models for that solution. We also incorporated other type of data. So we were taking short-term historical data, because long-term historical data is not relevant anymore, right? So everything that happened before does not look anymore like what is happening now. So everything, all the models that were trained on the data before in that specific use case were useless. So we had to take short-term historical data, and we used also the predictions of infections and incorporated that into the time series models used to predict the demand for different products in different regions. We also incorporated government policy, so what the governments actually, how the governments decided to react to COVID-19, lockdowns or quarantines, what was the rate of vaccinations in the specific country or region, and all of that was factored into the model. We also looked at unemployment claims, customer price index, producer price index, and mobility data, how people move from one area to another, and all of that was part of the model. Now, getting back to the technology, we were using driverless AI to build the model. So it allows you to build accurate models rapidly. It's very automated, so you can build really a lot of different models, and you do not have to spend a lot of time on writing code, but those models are still of a very high quality. So this is one of the things that is really important for us. We really invest in state-of-the-art development of algorithms that would still produce really good models, even though it's all automated. And on the other hand, our data scientists and our customers' data scientists can adjust the models and bring in also their domain expertise. And also part of the driverless AI platform is the explainability. That means that all the models that we created had automatic documentation, so we didn't have to spend time on writing documentation, as time was a really important factor in this project. And all the models also came with automatic explainability. That meant that we could actually explain how the model was built and why it was making the decisions it was making. We then could deploy the model into our MLOps platform, which is a one-click deployment platform. And again, all the governance and monitoring and all other aspects of the operations of that in that project were handled by that platform. So we kind of solved that deployment issue, and now we had a model that could be consumed by the business users. But the model by itself is something that, without something that wraps it, without something that actually gives you the results, it's very difficult for business users to understand what is the value. And we created an application for the business users to be able to drill down into specific SKUs in the different regions, and they could in real time see how the forecast is changing. This is called the demand sensing, because we are augmenting the forecast with information that is changing over time, and with the different variables from the data that was factored in to the models, we were able to improve the forecasts by really high percentage, and the company could then improve their supply and demand ratios. So this is one example of how we took something that had a specific business use case, collected the data, built the team around it, selected the technology, and then also made sure that the results of all of that effort are in the hands of the business users, and the business users can use this application and gain immediate value from it. There is a way for you to explore the H2AI hybrid cloud. It is available for free for 14 days, not entirely, and you can register and try it out on our website. And what I would like to show you is a couple of more examples of the models that, of the applications that we developed to show value to our customers. So this is our app store, and this is a demo app store, meaning that there are applications that are examples of different things that you could do with Wave to actually show the value, include your models in them, and show the modeling results in different ways. And I selected a couple of applications that to show that are of different use cases than what we were talking about. So here, for example, is an application for employee churn predictions. So we took a machine learning model that is the machine learning model is detecting whether an employee would leave the company. And if we are looking at what the dashboard here provides, is information about what are the top factors that are affecting the departure risk, what are the the states that are most risky for people to leave, and also what is the department that may have the most churn rates. You could also look at specific employees and see what are their specific risk for leaving the company. And if we would look at the employee risk factors, we can see here that employee number 111 is likely to leave because of overtime. So this making the chances of him to staying in the company lower. But the number of companies that he or that employee worked on is 5, and it has an increasing. Sorry, the other way around. The overtime, because he has the person has no overtime, then there is a decreasing a chance that that person would leave, and because he worked in 5 companies, there is an increasing chance that that employee would leave. If we would look at a different employee, we would see completely different factors for that specific employee to leave. And as an HR person going through this type of application, understanding what are the factors that may affect the specific employee. So in this case, because there is a frequently traveling employee is likely to leave, maybe in my evaluation of that specific person, I may advise that they would be moved to a different department where traveling is not required. So this is one type of application which is built on a machine learning model, but for the business user, it's all about what type of information they actually need and what type of information they require to answer their questions. So in this case, the main question of churn is what affects churn for each individual employee, and this application answers this question. A more healthcare-related application, again, we are working with a lot of different industries, is critical care management. So this is just a demo. It's not real data, but you can imagine that in the hospital, being able to monitor specific individuals and what is their chances of being at risk is very important. We can monitor the risk of every patient that comes to the ICU, whether they're at risk because they have high temperature or high blood pressure, and all of this data that is collected constantly about the patients. And this way, doctors may want to adjust their schedule, adjust what they need to actually do, who to prioritize, and so on. So this is again just the art of the possible, of the things that could be done in order to improve the lives of people, in order to answer your business questions in a better way. And here we really try to just show that there are endless possibilities when you actually translate a machine learning model that just answers whether a patient is at risk or not into something that brings value to the actual patients, to the doctors who are treating them. And this information needs to be displayed in a way that brings value to that specific person. So if I'm a doctor and I want to look at a patient's information, I need to know something about the patient, and then I need to see if, for example, the predicted risk was changing over time. Is it something that is affected by factors that are related to his temperature, heart rate, or oxygen saturation, and so on. And the last application is also HR related, and it's about analyzing documents for the language that is being used and whether that language is biased towards women or men. And what it does, it analyzes the documents that are descriptions, job descriptions of different positions that the company published, and gives a comparison of masculine inclination words and feminine inclination words. It allows you to see whether you are using in your job description superlative keywords that are known to be words that do not really attract women to apply for a position, and many other text analytics analysis or dashboards that can help you understand what kind of language is being used. If you have a lot of those, of course. If it's something trivial, if you have only 10 documents, you could just read through them. But if you have really a lot of documents and you want to know whether a certain type of language is being used in those documents, this is something that can be also answered with AI. At this, I would stop. And let me get back to the presentation. And I will share again the link to the hybrid cloud that you can try. Both in the hybrid cloud, you would be able to both look at the applications, some that I already shared and others as well. But you can also try driverless AI and train your own models and see whether you can get a model that maybe outperforms one of your existing models. You could also try out the deployment application, and you can also see with the open source wave how you could develop your own application as well. And at that point, I will ask if anybody has any questions.
Right. Hello, Lena. Thank you for your really interesting presentation. We had a lot of viewers all the time. Can you hear me?
Yes.
Wonderful. And let me just have a look at the questions. It's, by the way, still possible to ask questions now in the chat. So let's have a look. Maybe we just go with the first question, as we don't use Slido this time. Photios asks, is it possible to extract specific data, such as dates, values, codes names, from unstructured text in an efficient way?
Yes. That's a short answer. Yes. So actually, I'm an NLP engineer and natural language processing expert, and extracting data from unstructured data is actually one of my specialties. And it is possible to extract those type of data, and this is entity recognition, as we call it. So dates are entities. Many methods were, or like long time ago, it was all about rules and how to, like regex, right, regular expressions that would detect dates. But nowadays there are more methods how to do that, and it takes into consideration the context in which those.
I always hate that regex.
I don't know. Sometimes it's just a good old method. So
yeah. I want to meet one person that never has to look up any regex expressions.
Yeah.
But so basically, this is something that you could do, that you could also play around in the hybrid cloud with.
There are also there are open source libraries that would help you with that. In the hybrid cloud, there are two applications that detect specific entities in text, the Liber application, and there is another one for text analytics. And that's possible. Or another way that we are using this type of extraction is in our feature engineering in driverless AI. And this is automated. And therefore, you cannot see it directly because it's done behind the scenes. But it's one part of our platform as well.
Got it. Kevin asks, will there be a recording or summary of this workshop? Well,
yes.
A recording, yes. Summary, please let us know what you mean by summary.
I mean, I can share the slide deck, of course, if that's something that can be published.
Yes. We will share the slides, and we will also share a transcript as soon as we work through the transcript, because this is automatically transcribed. So,
with AI?
Yeah, I think so. I hope so. Well, I hope so. No, definitely. And let's see, the questions coming in. Thank you for your answer. Blash asks, as a new startup with a new idea, how to include other business end users as a very important stakeholder as the part of your first pillar in the development process. without giving them too much information about your idea, since it's not on the market and protected by your startup. So he works with a company and is just worried that they run off by themselves.
Well, one way is to include in your team someone who used to be in the business, right? So has the know-how and is part of your team, but actually understands what the business may need and what type of questions they may have. So you would know that you're in the right direction. And you can, as a startup, you can partner with one company, sign with them NDAs and other agreements that would protect you, but specifically develop with them your idea. They may invest in you and get something in return if you are giving them value.
So yeah, this is always a huge topic in startups that are very engineer driven or product driven. Please always consider getting someone on board that knows the business, that knows the ropes, who knows the ropes, just as Lena said, to be safe, on the safe side, and also to know how to actually speak and approach the right people and the right companies and partners. And yeah, our network can also help with that, Advantage Austria. So make use of these resources that are at your hands. So many people say, "Oh, nice session, congratulations, great presentation."
Thank you. I'm happy that you enjoyed it.
People enjoyed it, yeah. And we have a question coming in right now from Naresh. Please give some algorithm to deal with unstructured data in fully unsupervised mode.
Oh, it's like a test question.
It sounds like to me.
And there are different clustering algorithms. K-means is one algorithm that does completely unsupervised clustering, right? So there are many more. It's possible to. So there is one that we have in our the K-means algorithm is one that we're using in our open source technology that you can try in H2O. But there are many more. So I think that if you just search in Google for unsupervised clustering algorithms, you will get a list. So it depends on what you're trying to do, because there are many different types.
Depends. Maybe Naresh, let us know. And I think many people already started to register at your hybrid
so.
service.
If you do register, please use your company emails, your company domain emails. Because we do not allow personal emails
such as Gmail
or protection, so that we would not be misused.
Okay, this is just as Blaž asked right before. You have to be on the safe side and know what you do. So I wonder, our audience, what is the most tempting tool that you want to try out, or do you have any special use cases where you kind of think, okay, I now joined this workshop and I wanted to get a little bit better idea of how to start. So Joe-Fi asks, we have transformers in driverless AI. So driverless, this is your...
Joe-Fi is a colleague in H2O.
Okay, he answered that. Okay, wonderful. Well, we have transformers in driverless AI to convert unstructured text data to structured data for model training. He posts a link. So this is probably...
so this is for the first question, probably. So yeah. So there are different ways to transform text, and this is one of the I feel one of the more cool parts of the platform, because I am in the natural language processing area, and seeing that our platform handles text really in this state-of-the-art ways is very encouraging for me.
And well, let me just share what Joe-Fi posted here. You can learn more from training.h2o.ai.
Yes, this is our portal for training on our system, so you can get access to a demo environment for driverless AI and go through the questions and explanations in the training environment, and you can actually get a kind of a badge for completing different trainings on our website. So they're simple trainings and more complex specialized trainings on text analytics, on time series, on different use cases that you could solve with AI.
Thanks a lot. Yeah, what we would really need from you is kind of your slides and maybe the key 3 takeaways on where to head on with your AI journey from your workshop. And do we have any more questions here in the audience? I know it's already late in Europe, like 4:40. Let us know and post in the chat.
If you realize that you want to ask something and you forgot or you didn't want to ask in public, you can find me on LinkedIn and ask me there.
All right, so feel free to reach out to Lena on LinkedIn. Well, when they ask the questions here in the chat, we have their name and their company profile, so this might be hindering them to ask questions, unlike the anonymous questions we used yesterday.
Yes.
So this was great. We actually recorded the workshop. It will not be listed public and provided to those people who registered for this workshop with Lena's permission and with your colleagues' permission. Well, yes. I would say if we don't have any more questions coming in, we wrap this session up. And well, again, I have to excuse my colleague Clemens. It's his birthday today, and he went to eat a cake with his family. But he just sent his regards and says, great talk. Thank you so much to Lena Rampula, lead data scientist at H2O AI. And yeah, best wishes from Vienna.
And best wishes from Prague.
Thank you. Tomorrow we continue on with a program that might be also be interesting to you. I don't know, but it's all about investments and it's all about best practices in business models. And we host 2 very interesting sessions. One with Early Bird Ventures, Atomico, La Familia, and after that we move on to a session with Round 2 Capital Partners. So this should be interesting. And also we present the hackathon results tomorrow about noon. So thank you once again, Lena, and talk to you soon. Bye-bye.
Thank you. Bye.
Right, and this wraps up this special workshop, Navigate Your AI Journey, 5 takeaways for an impactful AI implementation, hosted by H2O AI. I hope you will join us again tomorrow for day 4 of Applied AI Conference. Don't be late to your meetings. Always check your agenda, especially to those meetings that you have already agreed to attend to. And with that, I wish you a nice evening or a nice day. Bye-bye.